Dear students, in our earlier classes, we have discussed two important lessons. One, motion of a body along a straight line and motion of a body in a plane. Now, in these two chapters, we didn't discuss what is the cause for this motion, what causes a body to move, and we get the answer for this particular question, and the topic is laws of motion, chapter number 5. And in this chapter, we are going to learn the cause for the motion of a body, what makes the body to stop, what makes the body to move, either along a straight line or even moving in a circular path or in any random path. Now, before learning, so we have to learn few basic physical quantities, and one such physical quantity is momentum. So, if I consider two bodies, one a rubber ball and the other is a shot put. So, this is the shot put. So, definitely shot put has more mass than the rubber ball, and they are dropped from the same height, and when they reach the ground, when we drop them simultaneously, their velocity is same. Velocity for both is the same. Velocity is independent of the mass. But as it falls on the ground, the rubber ball, it bounces back to some extent. Not the shot put, but when the shot put falls, you get to see some depression here on the ground. Correct? So, in this case or in this example, the velocity of two bodies are same, but masses are different, and because of the difference in the mass, as it falls, the shot put causes more damage to the ground compared to the rubber ball. And here we have a term that depends on both mass and the velocity, and we call it as quantity of motion associated with the body, and that is called momentum. It's called linear momentum. So, what is momentum? Momentum is defined as quantity of motion associated with the body. The word here quantity refers to the mass and the motion refers to the velocity. This momentum is represented by a symbol P, and it is a product of mass and velocity. It's a vector quantity. So, this is a vector, mass is a scalar, velocity is a vector. This is how we write the momentum. So, how do we mathematically measure the momentum? Momentum is the product of mass and velocity. Mass measured in terms of kilogram, velocity in terms of meter per second. So, therefore, in this illustration, which body has a more momentum? Obviously, the shot put. Why? Because of more mass, velocity is same for both. So, that is why we say that the momentum of the shot put is more, that is why it causes more damage. So, in this illustration, as the pendulum oscillates like this, it transfers momentum to the next, and that is transfer further to the next, and then it transfers to the last pendulum, and that is how they oscillate. So, it is again a good example for the momentum. So, how do we define momentum? Quantity of motion associated with the body, mathematically measured by the product of mass and velocity. More mass, more momentum, more velocity, more momentum. SI unit kg meter per second. It is a vector quantity. How do we write the dimensional formula of it? kg associated with the mass, meter per second, velocity L t minus 1 is the dimensional formula of momentum. So, see this illustration. In the first illustration, the car is at rest. So, there is no momentum. Why there is no momentum? Because velocity is 0. Momentum also becomes 0. In the next two illustration, second car and in the third illustration, The car is same, so their mass is same. But this car moves with more velocity, 20 meter per second. That's why velocity of this car is more than this. See, it moves with more velocity. Okay. So, greater the velocity, greater is the momentum, provided their masses are same. So, hope you have understood the term momentum. I will give you one more illustration, that is, we are going to have two bullets like this. Okay. One thrown, the other is fired from the gun. Now, which has more momentum? They are identical. So, mass is same. Momentum is product of mass and velocity. The one which is fired from the gun has more velocity. That's why more momentum. So, in this illustration, same mass but different velocity. In the illustration which is given here, correct, same mass, different velocities. So, this is one example. In the previous illustration, we had given example of the ball and the shot put, correct. In that illustration, velocity is same, but masses are different. Okay, right. So, hope you got the example, the equation. So, we are going to use all this equation in our future discussion. Okay, right. So, we know what is the meaning of the word state of rest and state of motion. So, what do you mean by state of rest? State of rest means if there is no change in position with respect to time, that is called state of rest. What do you mean by state of motion? If there is a change in position with respect to time and the surrounding, then it is called state of motion. Now, ability of the body to remain in the state of rest is called inertia of rest. A body continues to remain in the state of rest unless an external force acts on it. Till then it remains in the same state, that is called inertia of rest. Okay. You get to see an illustration where on a table a man pulls the cloth without disturbing the arrangement or the glasses, the plates on it. So, this is because of inertia of rest, and this happens only if you quickly pull the cloth. Okay. If you pull it slowly, everything will come along with the cloth. So, this is a good example where the body will continues to remain in the state of rest. Okay. This is called inertia of rest. Similarly, we have inertia of motion. What do you mean by inertia of motion? Ability of the body to remain in the state of motion is called as inertia of motion. Okay. Right. Now, see this here in this as the horse stops like this, correct, all of a sudden the horse stops, and when the horse stops, the rider will fall forward because he is in the state of motion. So, this is a good example for inertia of motion. Ability of the body to remain in the state of motion is called as inertia of motion. There are many more illustrations. So, all these things are again not a part of the syllabus. All this you have learned, in your lower classes. So, I am not going to waste much time on it. Okay. All right. So, every body continues to remain in a state of rest or along a straight line unless an external force acts on it, and the external agent we call it. So, therefore, what is force? Force is that external agent which changes the state of rest or a state of uniform motion of a body. So, how do you define force? Force is defined as that external agent which, when acting on a body, changes the state of rest or state of uniform motion along a straight line. That is called the force. And the force is a vector quantity. It's a vector quantity, and its SI unit is a Newton, and the equation for that is F is equal to m into a, that's how we measure it, mass into acceleration. In vector form we can write like this: vector F is equal to m into vector a, and the dimensional formula is mass into acceleration, mass and acceleration, L t minus 2. So force is a vector quantity, its assignment is Newton. Equation for the force is F is equal to ma. Vector form we can write vector F is equal to m into vector a, and the dimensional formula is m L t minus 2 is the dimensional formula of the force. So how do we define force? Force is that external agent which, when acting on a body, changes the state of rest or uniform motion along a straight line. Now what is Newton's? Again, you have learnt all the different laws. The first law is every body continues to remain in the state of rest or uniform motion along a straight line unless an external unbalanced force acts on it. The Newton's second law is that the rate of change of momentum, so this is the change in momentum divided by time, this is the rate of change of momentum, is directly proportional to the force applied, and changes takes place in the direction of the force. So this is what the second law, the rate of change of momentum is directly proportional to the force applied and takes place, that change takes place in the direction of the force. And Newton's third law, for every action there is equal and opposite reaction. So in this you can see a skate, this is a skateboard where he pushes the ground in the backward direction so that he can move in the forward direction. So action is pushing the ground in the backward direction, action. The reaction is the force exerted by the ground on him, that's why he moves forward. In one more illustration, where when a ball is dropped, it exerts force on the ground, and then you can see there is a change in the deformation of the ball takes place. The ball, again, if it is a rubber ball, football, or any kind of soft ball, it is get compressed. We cannot see that, but in the ultra motion you can see how the shape changes. Initially the ball exerts force on the ground, which is action, and in turn the ground exerts force on the ball in the opposite direction, and that is the reaction. So this is our illustration for Newton's third law, where we can write like this: F12 is equal to minus F21. Force exerted by the first body on the second is equal to force opposite, this is minus sign indicates opposite, okay, equal, see, equal and opposite, force exerted by second body on the first. And these two forces, they don't get cancel each other because they act on two different body. So here one of the body that experiences the force is the ground, which is the other body, the ball itself. So that is the one. So that's why they don't, even though they are equal and opposite, they don't get cancel each other. Okay. For example, on this, if I apply two forces, one in this direction, the other exactly opposite, now they cancel each other. Why? Because both the forces are acting on the same body. Okay. So forces get cancel each other only if they act on the same body, but in this case they don't get cancel each other because they act on two different bodies, right? So hope you have understood the illustration for the Newton's third law. Now let's learn about a term called mass. Now how do we understand what exactly mass? It is the amount of matter contained in a body. How much matter is present in a body, that is called as a mass. If there is a more matter, we say that the mass is a more. It is a scalar quantity. It is measured using physical balance. We have seen, the kind of the balance which they use in measuring, correct, the mass of a body in any of the shops. Either they use the digital balance, it's called physical balance, okay. It is either digital or there is an analog also, where they have to keep some standard masses, correct. So that is how. So nowadays they use the digital, or in good old days you must have seen they use in some of the shops they still use the physical balance, where there is standard load is placed on one side and the object whose mass to be measured is kept on the other side. then the mass of a body remains the same at all the places. So, mass does not vary from place to place, and then it is a fundamental quantity. So, this is about the mass. There is another term which is called the weight. So, mass and the weight, they are completely different. So, what exactly weight? So, weight is the gravitational force acting on a body. We know that the force is equal to mass into acceleration. So, when there is a body very close to the earth, its acceleration is equal to g. So, therefore, the gravitational force is given by the formula mg. Remember, this is an important formula. So, how do we calculate the gravitational force? Fg is equal to mg, where m is the mass of the body, and g is the acceleration when it is very close to the earth, not when it is at very large height. Okay. So, this is the gravitational force, and the gravitational force acting on the body itself is called the weight. So, the weight and the mass are two different physical quantities. This is what you need to keep in mind. Okay. If mass is 1 kg, then what is its weight? Then we can calculate W is equal to mg. M is 1, g is 9.8. So, 9.8 what? It is a force, right? mg is nothing but a force. What is the unit of the force? Newton. So, if the mass is 1 kg, then the weight of the body is 9.8 Newton. So, mass and the weight, they are not the same term, they are completely different. So, therefore, whenever somebody asks you what is your weight, then normally the answer what we give is that of the mass. For example, my mass is 60 kg. That is not my weight, that is my mass. So, mass is 60 kg. How I can calculate my weight? Multiply by 9.8. 16 to 9.8, whatever the answer that we get. So, that is my weight, and normally we have to express our weight in terms of Newton, not in terms of the kg. Are you clear with that? Right. So, let us see the differences here. It is the gravitational force which is acting on the body, and since it is a gravitational force, it is a vector quantity, because we know that force is a vector. That is why weight is a vector. That is the main difference between the mass and the weight. Mass is a scalar, weight is a vector quantity. It is measured using spring balances. Mass is measured using physical balance, whereas weight is measured using spring balance. So, later I will show you the diagram of that. Weight of a body varies from place to place. Why weight varies from place to place? Because this value of g, it varies due to the shape of the earth. So, that is why g varies from place to place. So, gravitational force varies from place to place, and that is the reason why the weight also varies from place to place and is a derived quantity. Mass is a fundamental quantity, weight is a derived quantity. Okay. Mass is a scalar, weight is a vector. Mass remains same at all the places, whereas weight varies from place to place. So, this is how we can write the differences, and then mass is measured using physical balance, whereas the weight is measured using spring balance. Okay. So, therefore, if you are given a mass of 10 kg and if you want to find the weight, W is equal to m into g. M is a 10, g is a 9.8, 10 into 9.8 is a 98 Newton. So, mass is 10 kg, weight is 98 Newton. Hope you understood the difference, because they are not the same quantities. Okay. All right. So, now look at the diagram of the physical balance. So, you must have seen here, there are two pans are there on either side, and then you need to place some standard mass here, standard mass, and then any side you can put the mass, and then one side you need to place the object whose mass is to be measured. Okay, that is physical. Now, this is the digital one. Okay, where you place the mass here, it shows the mass of that particular object. So these are physical balance. Okay. The spring balance you must have seen, you know, like this is a spring balance where they suspend some load here and you get to see the weight here. That's what they measure it in whenever you sell some papers and all, correct? Old papers or books, then they use this kind of a balance. This is called spring balance. Okay. So hope you understood the difference between the two. So let's try some numericals from this particular chapter. So I'm going to start with the first one. A constant retarding force of 50 Newton. Retardation means negative acceleration, correct? So retarding force means again a negative force. That's why I need to write F is equal to minus 50 Newton. Why minus? Because it's given in the statement that it's a retarding force. Is applied to a body of mass 20 kg. So mass is given 20 kg. See, based on this, I can immediately calculate the acceleration. F is equal to ma. A is equal to F by m. F is minus 50. By m is 20. The 0 will get cancelled. 5 by 2 is a 2.5 with a minus sign because retardation. So acceleration also has to be negative. So these signs are important. You need to write at the beginning itself. So we have found the value V, which is minus 2.5 meter per second square. Moving initially with a speed of 15 meter per second. So initial speed is given 15 meter per second. So first option, how long does the body take to stop? So it's given that the final velocity is 0. It's given how long does it take. So how long means we need to calculate the time. So now we know the value. See, we know here V, U, A and T relation. So V is equal to U plus AT. What is the value V? It's a 0. What is the value of U? 15. Minus because of this 2.5. Okay, 2.5. Then T we need to calculate. So 2.5 T is equal to 15, or T is equal to 15 by 2.5. So 15 by 2.5 is 2.528, 8 plus 4, 12. So we will get the value. Yeah, sorry. Yeah, 15 by 2.5 is a 12. So let's verify that. 15 by 2.5. Yes. Sorry, 15 by 2.5 is not 12, it's 6. It is 6. Yeah. 15 by 2.5. Fine. So that's 4. Yeah, correct. So 6 what? 6 a second, because we are calculating the time. After that, we'll calculate the second option. What is the second option? Distance travel before stopping. We need to calculate. Okay, so we'll use S is equal to ut plus half at square. You can even use this equation also. V square is equal to u square plus 2s. Okay, it's one and the same. Any one equation you can use, still get the same answer. Okay, S is equal to u. The value of u is 15 into time given is a 6 here, 6 minus because of the acceleration, and then half. The value of a is minus, which I have written it here, and then 2.5, and then into the value of t is 6, square of it, 6 square, there is 36 there, right. So S is equal to, so this is 15, 6, 60 plus 30, that's 90, minus 2.5 into, this is 18, okay, that's a 90 minus 18, 2.5. 18 into 2.5, that comes out 45. Okay. So 90 minus 45, you will get 45. 45 what? Meters. So that is the value of x. Sorry. Yeah. So that is the answer for the second option, which is 45 meter. Okay, so hope you have understood the problem. Very easy. So all this we have already used it earlier, right? So now the additional formula that we have used here is this, from today's lesson, which is F is equal to m into A, and this question again is from the exam. So let's try one more question from the exam. A constant force acting on a body of mass 3 kg, so mass 3 kg, changes its speed from 2 meter per second to 3 meter per second. So initial speed is 2 meter per second. The final is a 3.5 meter per second in 2 seconds. So t is equal to 2 seconds. The direction of the body remains unchanged. What is the magnitude and direction of the force? Okay. So to find the force, I can find acceleration, for which I can use v is equal to u plus at. V is a 3.5, the value of u is a 2, plus a, which is acceleration to be calculated, and the time is a 2. 3.5 minus 2 is equal to 2a. This is a 1.5 is equal to 2a, or a is equal to 1.5 by 2, which is 0.75 meter per second square. So that is acceleration. What about the force? F is equal to mass into acceleration. Mass is a 3. 3 into 0.75. So this is 3 5s are 15, 1 and 7 3s are here 21 plus 1 22, and then on multiplying you will get 2.25 Newton. So that is the force. They have asked what is the magnitude and the direction of the force. So this acts along the direction of motion. Since there is increase in velocity, see 2 meter to 3.5, since there is increase in velocity, means the force has to act in the direction. Okay. So if the force acts in the direction of the body, velocity increases. If the force acts opposite to the direction of the motion of the body, then the velocity decreases. For example, a body is moving like this. How can you stop? By applying a force in the opposite direction, correct? So therefore, if you apply a force in the opposite direction, then the velocity decreases. If you apply a force in the direction, then the velocity increases. That's why this force acts along the direction of motion of the body. Okay. Clear with the explanation, and hope you have understood how to solve this. Okay, right. Go through the next statement. A bullet of mass 0.04 kg. So mass of the bullet is given 0.04 kg. Moving with a speed. So initial speed is given 90 meter per second. Strikes a block and is stopped after a distance of 60 centimeter. It's stopped after a distance of, stopped means final velocity has to be 0, and distance is given 60 centimeter, which we have to convert. 60 by 100, that will be 0.6 meter. Okay. Now, what is the question? What is the average resistive force exerted by the block on the bullet? Okay. So we need to calculate. This is the first case, first value to be calculated. They have asked what is the average force. To find the force, we need always the acceleration, because F is equal to m into a. So here time is not given. That's why we need to use a v square is equal to u square plus 2as to find the acceleration. Final velocity 0, initial velocity 90, square of it, so 9 square 81, so 00, plus 2, acceleration to be calculated, distance s 0.6. Bring this to the left, minus 8100, that's equal to 0.6 into 2 is 1.2a, or a is equal to minus 8100 by 1.2. So, let us calculate this acceleration, which is 8100 divided by 1.2. 8100 divided by 1.2. That is 6750 minus 6750 meter per second square. Now, that is acceleration. So, what is the force? Force is equal to mass into acceleration. Mass is 0.04 into minus 6750. So, into 0.04, that is a minus 270 Newton. What is the meaning of minus? Minus sign indicates it is a retarding force, which is applied in the opposite direction. Since the force is applied in the opposite direction, the final velocity becomes 0. See, velocity decreases from 90 to 0. Why? Because a retarding force is applied, here it is, clear? Okay, let us see what is the next option. This is the second case. Now, how far would the bullet have penetrated? Okay. So, that means we need to find the value of S again. How far the bullet would have penetrated if the speed of the bullet had been 120 meter per second. Instead of 90, if the velocity is increased to 120 meter per second, then how far the bullet will travel. So, u is 120 meter per second, final velocity has to be 0, and the acceleration has to be the same as the earlier. Why? Because it is the same block which we are using. So, minus 6750 meter per second square. Are clear? So, therefore, let us calculate with the help of u, v and a, and then we can find the value of S. So, I am going to write that here, which is v square is equal to u square plus 2as. Final velocity is 0, initial velocity is now 120 square. 120, 12 square is 144 and then double 0, that is the square of 120, and then minus, because of the acceleration, minus 2 into acceleration is 6750 into distance, that is what we need to calculate. Now, let us bring this to the left, minus 14400 minus 6750 into 2 will give you 13,500 S. Minus sign will get cancelled, therefore, now S is equal to 14,400 by 13,500. That is 14,400 divided by 13,500. So, it will be 1.067 meter.